We're talking today about pattern making. Now, pattern making is the beginning of the foundry making process. That's what we start with. If we don't have a pattern, we can't make a casting. If we have a pattern, we can use that to create a sand mold. And when did all this start? Well, it really got going in the Civil War, when they were making cannons and they were making cannonballs and they were, making all the armaments for the war. The foundries of the Northeast grew quickly. This is a woodcut from D.D. Badger Company, but there were lots of foundries operating in the period of time from during the Civil War years in the 1860s. Now, when the war ended in 1865, all those foundries sort of looked around and said, "Oh, well, now what are we going to do?" So a lot of them went into the ornamental iron business. Now, let me take you back to the year 1975, and that was the year that I got into the foundry world. This is a shot from 1975, and you see that gentleman sort of crouched down on the left in the pork pie hat. That was Mr. Aubrey Brown, and Mr. Aubrey was my pattern maker when I started. And the day I started, he was 70 years old. He carved patterns with a pocket knife, made them all out of wood. And I was always constantly amazed with the talent that Mr. Aubrey had. But I also realized pretty fast that at age 70, I better apprentice someone to him really quick to try and learn his skill. So that's what happened. That's the way it got started. We began to apprentice people and began to work on how to build up patterns. Now, the way you can make patterns is from a drawing, a sketch. This is an ornamental pattern, obviously. And then you can carve that in wood. This is the way the patterns were made way back when. These are pictures of patterns from the turn of the century, probably date to about 1870, 1875. Original wood patterns. They need a little bit of cleaning work. You can also hand carve them. And we taught guys how to carve using chisels and white pine, and we would blow drawings up to full scale so that the guys would have a way to actually hand carve patterns. And this is again in the very beginning stages of our work in Alabama. Again, more hand carved wood patterns. These happen to be on the wall in my office. They are mahogany, and they probably date about 1885, somewhere in that range. Notice how they're mated, meaning there's a right and a left, or a front and a rear pattern. That's creating what's called the parting line of the casting, mated halves. Later, the foundries began to realize that if they used the wood patterns over and over, they would deteriorate or burn up or get lost or run over by a horse or whatever. So they began to utilize metal patterns. And so metal patterns, the master carving would be used only one time to make what was called a metalworking pattern. And typically they would be made of cast iron, like these patterns, which also date from late 19th century, metal patterns that would have been made or pressed into the sand molds. Later, the match plates were developed, and that is a pattern that has an impression on both sides of a plate. What this does is automatically finds the parting line of the casting. And the parting line of the casting is that point which separates the two halves of the mold cleanly, without breaking. We introduced plastics into the pattern making world in about the early 80s. We began to use hard urethane plastics. These are mixed plastics, part A, part B, and you mix them in the process of going back and forth from a mold, to a pattern to a mold, male, female, that type of thing. This is a typical plastic pattern being generated from female molds, rubber molds. There happens to be a collar for a lamppost, and you'll see more of this as we go through this presentation. And you see that's the blue portion of that is the pattern, and you see that the brown portion of this is what's called a core print, and that means that this casting will be made hollow with a dry sand core. And that brown portion of the pattern supports the core in the mold. Or match plates. Again, you can use wood for match plates, metal for match plates. Match plates are just a speeding up of the molding process. Again, the parting line is a crucial thing for any foundry. Anything that's backdrafted will tear the mold walls, and that's a real problem. So the parting line is something that we try and establish very carefully. This is an egg and dart trim, and you can see how the impression, you have the top impression, and you also get your first look at, well, actually second look at what is called the flask. And this little wood frame is the top half of the flask. On the other side, you have the bottom side of the flask. This is what's used to generate the sand mold. The top half is known as the cope, and the bottom half is called the drag. This is, again, a metal flask being used to generate a little collar type pattern. This is, the molder is holding the top half of the cope. The bottom half has already been rammed up with what's called green sand in the foundry world, but it's not really green. It's very, very black. And the blackness comes from the continual burning of the iron as it's being poured. You see the white thing in the middle, that is the core for that particular casting to make it hollow. And then, of course, the pouring occurs. Cast iron pours about 2,700 degrees Fahrenheit. Aluminum's 16 to 1,700, as well as coppers and bronzes in that range, temperature range. You can see how the parting lines are working out on these. At the point where the mold has part, you typically have metal that has to be ground off or removed. These have already been castings that have been ground already, but we call that plus metal. Metal shrinks in the mold, and for iron, the rule is 1/8 of an inch per linear foot. That means if we're going to make a 12-inch long casting, the pattern must be 12 1/8, so that when we dump it out and it cools, it shrinks, we have a 1 foot piece. So pattern makers make use of special rulers that are oversized. We also work with the pattern making world is a bit different from the machining world, where we have a part and we're going to machine it. We have to do a lot of considerations, but parting lines, shrinkage, and all of those things. So the pattern making world is a little bit different. Fortunately, we've been able to salvage this craft. Again, you sort of see some of the molds happening. A core printed piece on the right with a blue, what's called Dynacast mold on the left. That's a two-component urethane. And of course, quality is a huge concern, and pattern makers have to be very, very accurate with their work, especially when it comes to gating and risering, getting the proper flow of iron or bronze or aluminum, whatever you're making, into the mold. Improper flow can cause casting imperfections. This crack that's developed in this particular casting is called a hot tear. So that there's too much pressure being created on one area of the mold, creating a chill in another area. Another one is called cold shut, where the extremities of the mold aren't reached by the molten metal. But what we like to see is good, clean castings like these, and the buzzword in the foundry world is true to pattern, meaning you can never make a casting better than the pattern you used to make it. So everything is going to be a little bit less than the pattern, but the goal is always to make the casting which is true to pattern. And then, of course, there's all kinds of coordination that has to go on between the pattern shop and the foundry operation. First off is flask sizes, and typically foundries will have a particular sort of a shopping list of sizes that, you know, that they can operate in. Some work in bigger flasks, some smaller. Some have to be set up for air set type of castings, which would be this setup here where you have the wooden boxes. Typically a pattern set up in this fashion would be for very low production, you know, somewhere in the neighborhood of 1 to 30 or 40 castings, not a lot of castings. Also, that's the blue Dynacast that's in the pattern itself is in those boxes. And of course, you use flasks, and this is a really old one. Yes, that is kudzu.
Yeah.
And we don't have a cure for kudzu yet. Because if you've got a cure for kudzu, let me know, because we can patent that baby. We can clean up in Alabama. But you see, that's a big flask. You see the round things on the end. Those are called trunnions, and that just allows the founder to flip those big heavy molds using an overhead crane system. Another shot of those trunnions that I was talking about. The gating is a big deal. The gating of the patterns, a very big deal for a foundry. And you see on this one, the big riser that's set up next to that. That's because this particular little finial was being made solid in bronze. So we had to have a big, what's called a riser next to it, so that molten metal fills the cavity in the mold made by the pattern, and then as it cools, the metal from that riser helps feed that casting and prevents you know, a cold shut or defect in the casting. You get a solid metal casting. That ends up being cut off when the casting is cool enough to get out of the mold. Something that size, you probably want to wait about an hour to get it out of the mold. Again, sort of this match plate with gating attached. That's two impression pattern with gating running and feeding those two impressions made by that pattern. And you see the little kind of the dot in the very center. That is where a down sprue, or what's called a sprue, is cut through the top half of the mold through which the molten metal is poured. Again, more of a simpler, this is the bottom half of the mold, the drag portion of the mold, where the face of the casting is typically made, with the decorative side down, because impurities tend to rise to the top. So what you want is to get your decorative face on the bottom side of the drag, and then those are little feeders going into the casting. See how much smaller they are, because that's a very thin gauge casting, only about 1/4 of an inch thick. And then that's the top half, where again you see where the down screw goes to the little round button. Metal flows out through the runners and then feeds into the hollow impression through what's called an end gate. Now, how do we bring this old craft to teach us some new tricks? How do we bring this thing up into the 21st century? Well, what we are using now is laser scanning technology, and we have a portable handheld laser scanner that we can pack up into a case that fits in an overhead bin on an airplane. So we can take that scanner anywhere in the world. We can make a mold using the scanner, using the little targeting dots. It calculates the distance between the dots, and it remembers where the dots are. Yes, sir.
Do you have to control your Y dimension so it's fixed on your scanner elevation, or can you actually move it up and down and still give you the differential numbers?
You can move it anywhere you want it. As long as it's hitting those dots, and as long as it's in its correct field, you can move it anywhere, and it's reading.
So the operator can be moving up and down and still get the right data?
Yes, sir.
Okay.
Totally handheld. It's really quite amazing technology. Now, the point of all this scanning is to create a model, a three-dimensional model in our laptop computer. Now, what's great about the three-dimensional model is that we now have software. Ours is called Creaform, and we can change it. We can change the model. So for example, if we wanted it flatter, we could flatten it out like this image shows. Or if we want to correct for shrinkage, we can automatically correct for shrinkage, for whatever metal we're about to make. So this has been amazing. Yes, sir.
On your shrinkage, is that something that is calculated within the software, or are you having to input that?
We input it, you have to, because all the metals are different. But it's really, literally 2 clicks. So,
So it understands that ratio and actually enlarges it?
It does. Core shrinks. And that sort of solved a lot of problems for us because, for years people would say, oh, I really like that, but I wish it was bigger or smaller. Now you can scan it and make it whatever size you want. So model utilization has really been huge for us. 3-dimensional modeling. We can also refine things. We can zoom in on these models. We can change the details. We can refine the details, make them better. There are so many things that you can do, manipulate what you've got in the computer before you cut the pattern. Again, we're showing a 3D model of a pattern to be. In this case, the pattern maker selected or will eventually make only one of those leads. Now you've got a model and you got it in your computer. Now what do? Well, the next step is to cut the pattern. And for us, we use a three-dimensional router made by Haas. And Haas is an American maker. This is a shot of the tool running a tool path. And if you remember the slide before, you see that he's cutting one leaf of that pattern that we're generating. The red material that you see is called rim shape, and it is a tooling board that comes in various grades. It's not cheap, but it works really good because there's no grain in that rim shape. There, the finished leaf has now been cut in the rim shape. This shows that you can cut a 2/2 pattern at one time. In other words, you're cutting both sides of the pattern at one time. There's a fluted shaft that's been cut. Again, we're working on a project in Houston, restoration of Harris County Courthouse, and this is for their lamp posts, which are actually a recreation of some original Fisk posts that they had. This is again the rim-shaped pattern, pretty much straight out of the router, and we'll sort of chase this one through. And you can see now we're adding these core prints to the outside of the pattern. You can also see the core prints on the that would make the shaft hollow. You would ask me, why are you putting core prints on the outside of this pattern? And the reason is the depth of the fluting creates a background. So what we have to do is use what we call wing cores to get the deep fluting on the sides. I'll take you through some of that. These are the resulting core boxes, and you can see the reverse of the fluting in the bottom of the core box. So once these cores are set into the mold, a center core is set, then the wing cores are set, and we'll get fluting in 360 degrees on that particular pattern. There you see the completed pattern just prior to being mounted on a board, where they would separate in the 2/2 and mount it on a board, gate it, riser it, and it's ready to go. And there's actually a cast aluminum casting of that center shaft pattern. And there it is, prime painted. It's getting a round globe on top, and you've got an access door in the bottom. Turned out to be very, very, very nice. All router patterns, and all pretty much a copy of an original Fisk, J.W. Fisk lamp post right out of their catalog. And then everybody, wants to know how you price all of that. Well, just like you guys, it all boils down to materials and labor. I mean, you have so much time, but the tricky part is knowing, how long is it going to take in that router, exactly, how complex is it, how long is it going to take in the shop once the router's done, but really it's all time and material. So and I think you guys understand that part.
Material that you use to carve the pattern, that reddish looking material?
It's called Ren Shape, and
How do you
it's
spell that?
it's RENSHAPE,
Okay.
and it's also known as tooling board.
Okay.
It's a urethane-based material, and but it comes, it's got a nice hardness
It's
factor.
like a
to it.
high density urethane.
It's like a high-density urethane, and it's pretty tough stuff. What's neat about the Ren Shape is that it becomes the pattern. Whereas before, we might carve something, then make a plastic mold, and then make a plastic pattern. Now we're going straight to the pattern board. In other words, we're going model, cut, and then mount and gate. So
Can you just buy it in different sizes?
you can get all different thicknesses, lengths, but be forewarned, they think a lot of it.
Yeah. We've done a couple of signs in our shop, and we use our CNC machine, and they'll call for high density urethane, and I was shocked. I mean, $500 for a piece big enough to make a sign out of.
Oh, yeah. We recently made a pattern for an urn bowl for the U.S. Botanic Gardens, 14 feet in diameter. And we got pricing in on Ren Shape, and we quickly changed to poplar.
Yeah.
Okay, anybody else? Well, again, sorry, yes, sir.
Would you give us an idea of some types of restorations and locations you've been involved in?
Ooh, okay. Well, 38 years, that's a long time. we've been to a lot of places. And so I did bring some little brochures here, and it's got a lot of projects in there, including the Vulcan, which we completed in the Vulcan statue, which we completed in 2003, which is the tallest cast iron statue in the world. But we've also worked on the U.S. Capitol Dome. We've worked on the White House. We've worked on the executive office building next door to the White House. We've done lots and lots of work in New York, especially for the New York City Transit Authority. We recently completed a building restoration at 101 Spring Street in Soho, Raffles Hotel in Singapore. We just did finish some work in Guatemala.
Chicago subway.
Chicago
Kiosk.
subway entrances, and also the Navy Pier, which I think they're about to change. And all over the world, really, all over the place. So it's been a fun ride. Let me tell you. Back in the back.
Did you use this technology for all those projects?
No. This is all really new stuff. I mean, we've had our router now. This is our 4th year with the router. So this is all, pretty much cutting edge. We're still learning on this technology. And the next step for us would probably be a 3D printer. Yes, sir.
Between software, the scanner, and any other kind of incidentals that you need to run that system, what kind of price tag are you looking at to start?
This, not the router.
Not the router.
This.
Just that.
You're probably looking at about 30 for the software, and we got the demo model. Yeah, Randy.
Your sort of the Ren Shape material is it the lost material? Is that either recyclable or is it hard to dispose of?
It's inert, and we wish we knew what to do with the chips,
Yeah.
because we might generate a lot of chips. One of the great things about the router is it never seems to want to take a break. It never has the flu. Works weekends, nights. Just never seems to complain. Every now and then it'll fuss a little bit. I call it the pattern maker of the future. But I'll tell you this one thing other is that This machine and this technology didn't displace one guy, not one. In fact, it even made it so we want to hire more, because this machine can outpace a crew of 5 setting these up, and it's faster than that crew. So, I'm constantly, looking at, all these cuttings and going, when are we going to set this up?
Is the router clean enough, or do you spend a fair amount of time cleaning up tooling marks and?
Great question. I guess sometimes the guys get it perfect, and when they do the final tool path, it's with a very small bit. Sometimes as small as a 32nd bit, which is teeny tiny. But sometimes you get chatter marks, that have to be hand sanded out. It seems the bigger we get, the bigger pieces, the more hand sanding we have to do. But they do something fine with a lot of detail. Not much. Not much.
If you do have a blemish like that, you said sand them out as a subtractive process. Can you do an additive to that mold to build it back up and salvage that piece?
You bet. It's called Bondo. Works great.
I was hoping for something a little more technical.
Anyone else?
How do you hold it? How do you hold it down on the router while you're carving it?
Also a great question. We have the router has a metal deck, but we put about 4 inches of white pine onto that. We have a set drilling tap pattern. The first thing we do is put down that 4 inches of white pine, and then all the ring shape is attached to the white pine via wood screws in certain locations. And one of the real challenges of the guys when they program the tool paths is making darn sure they miss those screws that are attaching the ring shape down. And the white pine that you use is pretty much sacrificial. They'll cut on it for a year or so, but eventually it starts to look pretty ragged and uneven surfaces, and they have to replace it. So it sort of self-destructs. Anybody else? Well, I want to thank you today for the opportunity to come out west and be with you. I'll be around, so look me up if you have questions. And like I said, take a look at what we've got here. And thank you very much.
Is there a size limitation on this? I mean, or could you do something?
If it gets too big, anything, let's say, bigger than a 4-foot cube, you get to do it in multiple pieces. You would
well, I'll just, this is what I started with.
These are just a sticky disc, I'm
Right.
assuming.
Mm-hmm. And then once you scan it in, you can turn it around.
Can you regenerate things? I mean, a lot of your stuff is restoration work. Obviously, you're restoring because it's rotted and there's pieces missing. Can you take this model and add to it where pieces are missing and you can regenerate from historic photographs or something and try to establish the shape?
Yes, you can. All kind of stuff you can do with the model once you have what you can grab. Like for example, a lot of things we scan, we have maybe thick layers of paint on it. So your scan, it scans the paint too. It sees that stuff. So the guys can actually clean the paint off in the model and smooth the surfaces out before you go to the router. So, and add to it if stuff is missing.
And I don't do this, but periodically when we're traveling, so I'm not real good at it, but I'm just trying to get as many.
And is this always just a one-man job? I mean,
well, usually if we're going on a scanning mission, I'll send two guys.
okay.
Because so often they're working off of scaffolding or patterns, and you kind of need somebody to help. 2 guys.
No.
Are these sequential images or is it a continuum?
It's a continuum. It's totally continuous.
Something like this where you've got a front and a back, how do you get those two registered in the right?
You scan the front, then scan the back. And then, the guys can take the models and made them. So one of the things that works really great is if you have for us, and we do really sensitive builds. Like for instance, we recently went in and scanned some things to U.S. Treasury in Washington, and they didn't want messy mold stuff on the job site. They didn't, because it was in operation. They said, we don't want to give you samples, so we scanned their balustrade and then came back with new castings. Exactly.
It's magic.
Do your people who, do this?
You get 2 levels beyond anybody's understanding. It's magic.
Great. It's totally magic.
The people who do the scanning and the computer work, do they generally have a casting background, or do they have a computer graphics background, or?
Well, they have both.
Okay. That seems like a hard person to find.
It is. I'm telling you.
Someone who's spent time in a foundry and a computer,
I'll tell
graphic
you,
designer is not easy, man.
my lead guy, started off making models. I made him a pattern. And then every day I'd see him, he'd say, man, I got on the computer last night, I was doing this, and that went for years. And finally, when we bought this, we made the decision to buy this technology, and the router, I came to the guy and said, look, this is a big, I ask a lot of you, but you have to go to school. I mean, these folks trained you. You're going to have to go to school, and he did it all. Just now I've apprenticed a guy to him.
So how long is the schooling process for this?
They can do it in 2 or 3 weeks. Yeah.
At their facility, I'm assuming?
Usually. They will send people too. Now this is Canadian.
Do they have a lot of competitors, or is there a number of people?
We looked at, there are a lot of people doing laser scanning now for 3D models. And most of the time, people are scanning whole buildings, stuff like that. That didn't suit our needs. We have a lot of scanners that operate on tripods, where with an arm, but they're big and bulky, and, to get that, you'd have to drive it there with a truck.
Going up on scaffold and things.
Right, exactly. So we kept looking for this kind of technology as being most applicable to what we do. So now we take it and work on all kinds of stuff.
And how long do you expect to have this? Or is this the kind of thing that every 10 years
It'll change. It'll change. You can do it. It'll change. Yeah. But the newest stuff is going to be the priciest stuff. So, what we want is to be able to maintain a machine like this. Like we had about 4 years ago. We've only broken it once. But yeah, we'll keep our eye on what's new, and I'm sure it'll change.
Have you ever scanned a part and then mic'd a part? And do you know the tolerance?
Within 1/1000, the scan is 1/1000.
And the guys that do this, they scan it and it's perfect. It looks just like that.
So is this here a scanning issue, or is that something
That's
you just...
me just holding it. Because I've got it in my hand and I'm not real good at it. When they scan it, it's perfect.
Well, and also, if you put it down on the table, it starts to pick up the table.
I've done it where it's picked up the watch, but
Does it need the targets?
Yes. But they're peeled right off. It creates the coordinates.
when you start, there's a little, start with a little arrow. See that little X? And that's when it really starts to
And the distance is important too. You see how if you get too close, you want to stay in the green. The distance between the scanner and the object is important.
What's the maximum size object you can scan?
We can scan up to like 4 by 4, 4 feet by 4 feet. But what happens is you end up scanning areas. In other words, you may scan this much and then move over this much. and then keep, kind of piecing it all together to create a model of something big.
So those scans almost have like a maximum file size.
They get huge.
Right.
They can
be multi-gigabytes of information.
Oh, yeah. Terabytes. They get big. And then the lines of code necessary to cut these things, they get huge.
So